Right now, somewhere on the surface of Mars, a planet that has been spinning silently for 4.5 billion years, there may be something alive. Not something big, not something that walks or breathes or looks back at the stars the way we do. Something small, microscopic, hidden in the dust and rock beneath a sky that hasn't seen rain in hundreds of millions of years. And 50 years ago, we may have already found it. The data was real, the experiments were successful, but you were never supposed to know. To understand what happened on Mars in 1976, you first need to understand the world that sent the mission there. NASA had just done the impossible. They had taken human beings, made of bone and blood and nerve, and placed them on another world. 12 men walked on the moon. 12. And then, almost without fanfare, it was over. The space race was won. The Cold War rivalry that had given NASA its unlimited budgets, its urgency, its almost reckless ambition, was cooling. And with it, the money vanished. The original dream had been called the Apollo Applications Program, an extension of the moon landings that would press humanity onward to the next great frontier, Mars. Using everything learned from Apollo, NASA was going to send people to the Red Planet in the 1970s. In the decade that also gave us disco and polyester suits, we were going to set foot on another world. But that dream died in a budget meeting. What survived was something smaller, something more modest, but in terms of what it would discover, something that would shake the foundations of what we thought we knew about life in the universe. 2 spacecraft, identical twins, each carrying an orbiter to map the planet from above and a lander, a robotic laboratory, to touch down on the surface. The mission was called Viking, and it was given one primary objective above all others: to determine whether there is, or ever has been, life on Mars. $600 million 1970s dollars. The most expensive robotic mission ever launched. And at the heart of it, a question so profound that answering it incorrectly would be worse than not answering it at all. Because there are some questions where the wrong answer doesn't just embarrass you, it changes everything. On August 20th, 1975, Viking 1 left Earth. Not with a bang, with a controlled, precise, thunderous ignition that shook the Florida coastline and turned the pre-dawn sky into noon. 20 days later, its twin, Viking 2, followed it into the sky. They were not fast. This wasn't Star Wars. There would be no hyperspace jump, no warp drive, just 2 machines, drifting through the void on the slow gravity-assisted arc that we call a Hohmann transfer orbit. 11 months. That's how long the journey to Mars takes. 11 months of flying blind through interplanetary space with no ability to course correct in real time, no human hand on the controls. Just 2 computers, 1970s computers, navigating by mathematics and trust. For context, the smartphone in your pocket right now has roughly 10 million times more processing power than the computers guiding Viking across the solar system. And we sent it anyway, because that's what explorers do. After 11 months and hundreds of millions of kilometers, Viking 1 slipped into Mars orbit. And for the first time in history, a human-made machine was circling another world with the specific intent of landing on its surface. From here, a signal from Viking took 19 minutes to reach Earth. 19 minutes of radio waves traveling at the speed of light just to cross the distance between us and them. What that means is this: by the time Viking's first signal of the day reached Earth, the spacecraft had already been operating alone for 19 minutes. Whatever happened without us. The machines were on their own. On July 20th, exactly 7 years after the first men landed on the moon, Viking 1 began its descent. At first, it came in fast. Impossibly fast. The thin atmosphere of Mars couldn't break it the way Earth's could. The heat shield screamed with temperature, 8 times the speed of sound, and still falling. Then the parachutes. At 6 kilometers altitude, chutes deployed and yanked the lander back to something approaching sanity, from hypersonic to merely terrifying. But Mars is not Earth. Its air is a whisper of Earth's. The parachutes could only do so much. At 1.5 kilometers above the surface, the parachutes cut away, and the rockets fired. 6 landing thrusters, arranged in pairs, burning clean so as not to contaminate the ground below, the very ground they had crossed the solar system to study. at 8.5 kilometers per hour, roughly walking speed. Viking 1 touched the surface of Mars. Then the first image came back. And for a brief, perfect moment, every human being who saw that image felt the same thing. We were no longer alone in the universe. At least, not alone as a species of explorers. We had reached another world. But the real question, the question that justified every dollar, every sleepless night, every calculation, was still unanswered. Is anything else out here? The biology package aboard Viking was a marvel of miniaturization, a fully functioning laboratory sealed inside a box that would fit in your kitchen, built to run 3 separate experiments, each one designed to detect the thing no instrument had ever been designed to look for before: life. First, the arm reached out and scooped up a small sample of Martian soil. Then the laboratory went to work. Experiment 1. The gas exchange. The simplest idea in the world. Drop some water and nutrients onto the soil. If anything is alive in there, truly alive, it will eat, it will drink. And like every living thing in existence, it will produce waste gases as a byproduct. Burping and farting, as one NASA engineer put it, with a brevity that somehow made the whole thing even more extraordinary. The result was positive. Gases were released. Exactly the kind of gases you'd expect from biological activity. Now, that alone wasn't enough. The same gases could have been produced chemically. Existing compounds in the soil activated by the water. The scientists noted it, filed it, and moved to the next test. Experiment 2. Pyrolytic release. This test was looking for photosynthesis, the process by which plants on Earth capture sunlight and turn it into energy. The idea being that if Martian organisms had evolved beneath that feeble, distant sun, they might have developed similar machinery. The result was a slight positive signal, not overwhelming, but it was there. Experiment 3. The labeled release. This was the most elegant experiment of the 3, and the most specific. It also used nutrients dissolved in water. But this time, the nutrients were laced with a trace of radioactivity. The idea was simple. If something in the soil ate the nutrients and exhaled CO2, and if that CO2 carried the radioactive signature of the nutrients, then there was only one explanation. Something alive had taken in the food, metabolized it, and breathed it back out. Not chemistry, not geology, life. And then, Viking 1 returned its result. Strong, positive. The labeled release experiment had found exactly what it was designed to find: evidence of biological activity on Mars. And 2 months later, when Viking 2 landed in a completely different region of the planet, Utopia Planitia, 4,000 kilometers away from its twin, it ran the same 3 experiments, and it found the same results. Positive, positive, positive. So why didn't you grow up learning about the day NASA found life on Mars? Why is it that the most significant scientific discovery in the history of our species, if that's what it was, barely registers as a footnote in most school curricula? The answer is complicated, and it reveals something important about how science works when the stakes are incomprehensibly high. There was a 4th experiment on board Viking, not a biology test, something more fundamental. The GCMS was designed to detect the chemical building blocks of life, the raw ingredients, the molecular scaffolding without which no living thing can exist anywhere in the universe. Organic molecules, long chains of carbon and hydrogen, the architecture of biology itself. The GCMS heated a sample of Martian soil to 500 degrees Celsius, vaporized it completely, and then examined every single molecule floating in the resulting cloud. What it was looking for were organics. What it found was nothing. No organic molecules, not a trace. And in that single result, the extraordinary became merely interesting. The biology experiments, 3 tests returning positive signals, were reclassified as inconclusive, because without organic chemistry, how could there be life? The official conclusion from NASA was cautious, measured, scientifically defensible. Life on Mars, unproven, not disproven, not confirmed, inconclusive. And the world moved on. But one man didn't move on. Dr. Gilbert Levin was the man who designed the labeled release experiment. He had given years of his life to the question of life on Mars. And when the data came back, when his instrument returned that strong, unambiguous positive signal, He believed what he saw. For the rest of his life, until his death in 2021, Dr. Levin maintained that Viking had detected life on Mars. He published papers, he made arguments, he pointed to the data. And for 50 years, he was largely dismissed. But here's what makes this story even stranger. In 2014, 38 years after Viking, the Curiosity rover made a discovery that NASA published without perhaps fully appreciating what it meant. Drilling into a sample of Martian rock, Curiosity found something preserved in the ancient stone. Organic molecules, not contamination, not a measurement error. Genuine, preserved organic chemistry. The building blocks of life, in Martian rock that had been sealed away for hundreds of millions of years. In 2018, Curiosity found more in a different sample of mudstone. And then in 2025, the rover found something that stopped scientists mid-sentence: long-chain hydrocarbons, complex molecular structures remarkably similar to the backbone of fatty acids, the very molecules that are believed to have been central ingredients in the primordial soup from which life on Earth first emerged. Think omega-3, think omega-6, the molecules that form cell walls, the molecules that make biology possible, on Mars. Which means that when NASA concluded in 1976 that Mars didn't have the building blocks for life, they were wrong. And if they had known then what we know now, the strict criteria that classified Viking's results as inconclusive would no longer apply. The building blocks were there. The biological activity signals were there. The missing middle, the explanation that connects those two facts, has never been found. But then again, neither has anyone looked very hard. In the 5 decades since Viking, NASA has landed 5 more spacecraft on Mars, and not one of them has ever carried an instrument designed to replicate the labeled release experiment, the one experiment that returned the clearest positive signal for biological activity in Martian history. Not one. Let's sit with this for a moment. If the labeled release experiment was right, and 50 years of new discoveries haven't given us strong reason to say it was wrong, then Mars is not dead, was not dead, may not be dead. And if life existed on Mars, even once, even briefly, even in the form of microbes too small to see, the implications are staggering. Because the solar system formed from the same cloud of material. Mars and Earth were born from the same stellar debris, built from the same atoms, warmed by the same young sun. If life arose independently on Mars, it means life isn't rare. It means life is what chemistry does when given the right conditions. It means that around every other star, in every other solar system, wherever water touched rock and molecules had time to meet, life may be the rule, not the exception. Not alien in the science fiction sense, not with ships and cities and languages, but alive, in some form, by some chemistry, doing the extraordinary, improbable, magnificent thing that life does, persisting. Viking 1 operated for 6 years, 2 months, and 21 days before contact was lost. It is still there, right now, as you watch this. Standing in the dust of Chryse Planitia, on a planet where the temperature drops to -73 degrees at night and the sky is the color of a bruise. It transmitted more than 51,000 images. It monitored the Martian weather through 3 full Martian years. It waited, patiently, for someone to tell it what to do next. And then it waited alone. Dr. Gilbert Levin lived to be 97 years old. He never stopped believing his experiment had worked. He never stopped asking the question. And the universe, as it tends to do, has spent 50 years slowly, incrementally, quietly suggesting he might have been right. There is a moment in every great discovery when the data points somewhere, and the choice is made whether or not to follow it. Viking pointed somewhere. The GCMS said wrong direction, and we turned away. But every discovery since, every organic molecule pulled from Martian rock, every sign of ancient water, every measurement suggesting that Mars was once warm, wet, and hospitable, has been pointing us back to the same question. What is in that soil? We are going back to Mars, humans, this time. Not just our machines, but us, with our hands and our eyes and our stubbornness and our desperate, defining need to know. And when we get there, we will carry better instruments than Vikings. We will drill deeper, test more carefully, look harder. But let's be honest with ourselves about what we're doing. We're going back to check. Because 50 years ago, Two machines crossed the solar system, touched down on an alien world, and ran tests that came back positive. And instead of asking what that meant, we decided it was easier to say inconclusive. The universe is under no obligation to tell us its secrets, but it leaves clues. And those clues, buried in the data from an experiment that ran in 1976 and was quietly set aside, have been sitting there this entire time, waiting for someone to look again. The Viking biology experiments ran in 1976. No subsequent Mars mission has replicated the labeled release experiment. In 2025, the Curiosity rover discovered long-chain hydrocarbons in Martian mudstone, structurally similar to the building blocks of fatty acids. Dr. Gilbert Levin, designer of the labeled release experiment, maintained until his death in 2021 that Viking had detected life on Mars. The question remains open. What if the next great war isn't fought on Earth? What if it's fought over something hidden in the darkness of the moon? Right now, two superpowers are racing toward the exact same location for a reason most people have never heard of. And once you understand what they found there, you'll never look at the moon the same way again. Click the video on your screen.